For millennia, the dream of flight was a persistent, almost primal human aspiration. People gazed upward, watching birds soar on invisible currents of air, and wondered why humanity was bound to the earth. This yearning found its expression in myths and legends: Icarus with his waxen wings, Leonardo da Vinci's sketches. These early imaginings, while not yet grounded in aerodynamics, spoke to a desire to conquer the sky. Many brave, often foolhardy individuals tried to realize it, constructing contraptions of wood, cloth, feathers, usually with disastrous results. Yet their failures narrowed the path for those who followed. The true scientific pursuit of flight began to take shape in the 19th century. The moment that transformed the dream of flight into a tangible reality arrived on a cold, windy morning, December 17, 1903, on the desolate sand dunes of Kitty Hawk, North Carolina. Wilbur and Orville Wright achieved what had eluded humanity for all of recorded history. The Wright Flyer, built of spruce and fine muslin, a delicate biplane braced with wires, wood, wire, cloth. Their genius was control in 3 dimensions: pitch, roll, yaw, using wing warping, a hip cradle, a forward elevator, and a rear rudder. They built a lightweight 4-cylinder gasoline motor producing just 12 horsepower. That morning, the Flyer lifted from its rail into a stiff headwind. The flight was short and unsteady. 12 seconds, 120 feet, less than a modern 747's wingspan. A sputtering, lurching hop, a gentle landing. It seemed insignificant, but for the world, it was everything. The outbreak of World War I in 1914 transformed the airplane from curiosity to weapon, at first reconnaissance, then directing artillery. Soon, pilots engaged each other in the air. Fragile biplanes, open cockpits, simple instruments, temperamental engines. From pistols to rifles to machine guns, the interrupter gear fired through the propeller. Legendary fighters took form, and larger aircraft became bombers. War forced better engines, stronger structures, more speed and maneuverability. By 1918, surplus aircraft and trained pilots set the stage for civil aviation. The 1920s and 30s became the golden age. Daring flights, air races, first airlines. Converted bombers carried mail and a few brave passengers. Noisy, cold, uncomfortable, but a new era. Designs moved to enclosed cabins and larger monoplanes. Wood and fabric gave way to all-metal pioneers like the Junkers F-13. The Ford Trimotor and Douglas DC-3 made air travel more reliable, comfortable, and accessible. World War II triggered an unparalleled surge in aeronautical development. Nations poured resources into fighters, bombers, and transports. Aircraft became faster, stronger, higher flying. Flimsy biplanes were relics. Supercharged, all-metal monoplanes ruled. Spitfire, P-51, Bf-109, stressed skin aluminum, enclosed canopies, retractable gear, liquid-cooled V-12s and massive radials, supercharged for high-altitude power. Armament grew from machine guns to heavy cannons. Strategic bombers, B-17, B-29, Lancaster, carried immense loads over vast distances. Crews of 10-plus pressurized cabins, precise bomb sights, multiple defensive turrets. Interceptors, early missiles, and the first jets emerged to counter them. 6 years compressed decades of progress, design and mass production. Aerodynamics, engines, metallurgy, systems, all advanced, but pistons neared their limits. Near-sonic prop tips sapped efficiency. A new propulsion was needed, and secretly born. The final years of World War II gave birth to the jet engine. Germany's Me-262 and Britain's Gloucester Meteor arrived, but too late to change the war. Jets replaced pistons, cylinders, and propellers with continuous combustion turbines. Thrust and speed propellers couldn't reach. Post-war refinements saw jets dominate the skies, and commercial aviation watched closely. Faster flights shrank the world. The de Havilland Comet offered sleek, quiet, high-altitude travel, until metal fatigue disasters grounded the fleet, teaching vital safety lessons. The Boeing 707 and Douglas DC-8 inaugurated mass jet travel in the late 50s. Larger, faster, longer-range jets made non-stop transatlantic routine. Jet glamour gripped the public as airports modernized. The 747 democratized the skies. Twin aisles, twice the passengers, lower costs. It became an icon of global connectivity. Concorde crossed the Atlantic in under 3 hours at twice the speed of sound. A technological masterpiece, if commercially limited. So, yeah, it was extraordinary. From the 1980s to today, change came through materials and computing. Jet principles persisted, but aircraft became vastly more efficient, safer, more capable. Engineers moved beyond all aluminum, adopting carbon fiber composites for strength with less weight. Lighter structures resist fatigue and corrosion, enabling major fuel savings. The glass cockpit replaced clusters of dials with a few multifunction displays. Pilots get integrated views of systems, navigation, and flight path. Fly-by-wire, first on military jets, then the A320, mediates inputs through computers to actuators, keeping flight within safe envelopes. Flight management optimizes routes. Radar maps storms. TCS lets aircraft talk, alerting crews and guiding evasive action. Boeing 787 and Airbus A350, largely composite, are lighter, with larger windows and more comfortable cabins. High-bypass turbofans are quieter and cleaner. Seatback entertainment, Wi-Fi, and advanced air filtration redefine comfort. From a 12-second hop to a 17-hour non-stop online, an astounding evolution. As we stand here in 2026, the story of aviation enters its next chapter. Sustainability and efficiency now drive innovation. Small, all-electric aircraft emerge for training and commuter hops. Zero in-flight emissions, drastically reduced noise, lower costs. But battery energy density limits range and capacity for now. Hybrid electric systems progress rapidly. Sustainable aviation fuels cut carbon in today's engines. Drones prove unmanned flight. Autonomous cargo aircraft are on the horizon. Removing pilots could save weight and cost, but passenger autonomy faces major regulatory and public hurdles. Expect a diverse sky, sustainable long-haul, hybrid regional links, on-demand electric air taxis. The same desire that drove the right still propels us. From wooden wings to Wi-Fi at 35,000 feet. The future of flight is cleaner, quieter, more integrated than we can yet imagine. It's an exciting time.